In this lecture, I will make the case that climate change that we see around us is caused by human effects on the climate system. After studying this chapter, you should be able to answer the following questions. How do we know the nature and cause of recent climate change? And what are some of the observable effects of this change on natural systems? The idea that humans are impacting the climate system is not new. Svante Arrhenius, a Swedish physical chemist and Nobel Prize winner, developed a theory to explain the ice ages, and in 1896 he was the first scientist to attempt to calculate how changes in the levels of carbon dioxide in the atmosphere could alter the surface temperatures through the greenhouse effect. Arrhenius was the first person to predict that emissions of carbon dioxide from the burning of fossil fuels and other combustion processes were large enough to cause global warming. In his calculation, Arrhenius included the feedback from changes in water vapor as well as latitudinal effects, but he omitted clouds, convection of heat upward in the atmosphere, and other essential factors. His work is currently seen less as an accurate prediction of global warming than as the first demonstration that it should be taken as a serious possibility. The exact extent to which humans influence the Earth's climate system remained a source of discussion for decades after Arrhenius published his initial paper on climate change. Pivotal evidence that human activities are increasing atmospheric carbon dioxide came from an observatory on top of the Mauna Loa volcano in Hawaii. The observatory was established in 1957 as part of an international geophysical year to provide atmospheric data in a remote, pristine environment. Measurements taken by atmospheric chemist Charles David Keeling showed CO2 levels increasing about 0.5% per year. The Keeling curve, presented on the next slide, has been continuously updated since 1958 and shows that carbon dioxide concentrations have risen from 315 parts per million in 1958 to 393 parts per million in 2012. The line is jagged because of annual fluctuations. Concentrations decline each May as plants in the northern hemisphere, which has far greater continental area than the southern hemisphere, begin photosynthesizing and capturing carbon dioxide. During the northern winter, trees go dormant and stop removing carbon dioxide from the atmosphere, and plant decay releases carbon dioxide, causing CO2 levels to rise. Measurements of atmospheric carbon dioxide taken at the top of Mauna Loa, Hawaii, show an increase of about 2.2% per year in recent years. Monthly mean carbon dioxide, red, and annual average carbon dioxide, black, track closely with the general trend in global temperatures, blue. Because the climate is so complex, climate scientists worldwide have collaborated in collecting and sharing data and in programming models to describe how the climate system works. Evidence shows regional variation in warming and cooling trends, and there are minor differences among models. But among climate scientists who work with the data and models, there is no disagreement about the direction of change. The evidence shows unequivocally, as in the Mauna Loa graph, that climate is changing and the global average is warming because of increased retention of energy in the lower atmosphere. In the final IPCC report on climate change 2014, climate scientists concluded that humans are changing the climate. This impact of humans on the climate system was made clear by the IPCC. Humans-based input of carbon dioxide since the start of the Industrial Revolution is the greatest contributor to radiative forcing. In this figure from the final IPCC report, it is clear that humans emit a huge amount of carbon into the Earth's atmosphere, approximately 40 gigatons per year. It is interesting to note that when Arrhenius wrote his initial paper in 1896, annual human input was approximately 2.5 gigatons of carbon dioxide, and fossil fuel was small relative to forestry and other land use emissions. Today, annual anthropogenic carbon input to the atmosphere is nearly 40 gigatons. From the graphic, about what year did humans start emitting great amounts of carbon dioxide? The most comprehensive effort to describe the state of climate knowledge is that of the Intergovernmental Panel on Climate Change, IPCC. As the name indicates, the IPCC was a collaboration among governments with scientists and government representatives from 130 countries. The aim of the IPCC was to review scientific evidence on the causes and likely effects of human-caused climate change. In 2007, the IPCC issued its fourth assessment report, the result of 6 years of work by 2,500 scientists. The 4 volumes of the report represent a consensus by more than 90% of all scientists working on climate change. The conclusion is a 90% certainty that observed climate change is caused by human activity. Subsequent reports have raised that to a 99% certainty. You can view the report with figures and related documents at the IPCC's website. The IPCC's fifth and final assessment report was published in late 2014. The IPCC's fourth assessment report presents a variety of climate scenarios for predicted emissions of greenhouse gases. For each scenario, the IPCC modeled future emissions starting in 2000. Scenarios differed in expected population growth, economic growth, energy conservation and efficiency, and adoption of greenhouse gas controls or lack thereof. The different scenarios project a temperature increase by 2100 of 1 to 6 degrees centigrade, or 2 to 11 degrees Fahrenheit, compared to temperatures at the end of the 20th century. According to the IPCC, the best estimate for temperature rise is now about 2 to 4 degrees centigrade, about 3 to 8 degrees Fahrenheit. A change of 4 degrees centigrade is just slightly less than the difference in global temperature between now and the middle of the last glacial period, which was about 5 degrees centigrade cooler. Observations since 2007 show that all the IPCC scenarios were too conservative. Greenhouse gas emission, temperature, sea level, and energy use have accelerated faster than even the worst IPCC predictions. See the next figure, bold line. There is serious concern that increased heat stress and drought could cause increased death, as well as crop failure and new waves of refugees from drought-stricken regions. Emissions scenarios modeled by the IPCC, colored lines, are considerably lower than the observed emissions data, black line, indicating the IPCC projections have underestimated current and future climate change. Values represent fossil fuels, cement production, and land use change. One place that we are likely to continue to see significant change is in the rise in sea level. This figure shows the approximate change in land surface with 1 meter, 3 feet, of sea level rise, a change that is likely by 2100. If no action is taken, sea level may be 2 meters, 6 feet, or more. This graphic shows the source of greenhouse gas emissions from 2010. The energy sector, electric companies, is the major source of greenhouse gas emissions. This is why the Obama clean power rules were so important. With the election of Trump and the appointment of climate change deniers to lead the EPA, the Clean Power Plan will be scrapped. Since pre-industrial times, atmospheric concentrations of carbon dioxide, methane, and nitrous oxide have climbed by over 31%, 151%, and 17% respectively. See the following figure. Carbon dioxide is by far the most important of these because of its abundance and because it lasts for decades or centuries in the atmosphere. Fossil fuel use is responsible for 80% of carbon dioxide emissions. Cement production furnaces and burning of forests and grasslands are also major sources. Together, these release more than 33 billion tons of carbon dioxide every year on average. About 3 billion tons of this excess carbon is taken up by terrestrial ecosystems, and around 2 billion tons are absorbed by the oceans, leaving an annual increase of some 4 billion tons per year. If current trends continue, carbon dioxide concentrations could reach about 500 parts per million, approaching twice the pre-industrial level of 280 parts per million by the end of the 21st century. This graph shows us the historical inputs of greenhouse gases into the atmosphere. Methane from animal husbandry and nitrous oxide from fertilizer use remain potent sources of greenhouse gases and indicate that industrial-scale agriculture, with its dependence on manufactured fertilizers and beef production, is an important driver of climate change. This graphic shows the production of greenhouse gases by industrial sector, figure A, and by country, figure B. The IPCC noted that the changes in the Earth's climate system are unprecedented. Let us now take a look at these changes in more detail. The American Geophysical Union, one of the nation's largest and most respected scientific organizations, has stated that, as best as can be determined, the world is now warmer than it has been in the last 2,000 years, since the beginning of civilization as we know it. If current trends continue, by the end of the century, it will be hotter than at any point in the last 2 million years. The average global temperature has climbed about 0.6 degrees centigrade, or 1 degree Fahrenheit, in the past century, and 19 of the 20 warmest years in the past 150 years have occurred since 1980. This warming has resulted in some important changes. Global sea level has risen approximately 20 centimeters, or 8 inches, in the past century. Polar regions have warmed much faster than the rest of the world. Permafrost is melting. Houses, roads, pipelines, sewage systems, and transmission lines are collapsing as the ground sinks beneath them. Arctic sea ice is less than half as thick and half as extensive in summer as it was 30 years ago. As more heat-absorbing water is exposed and less heat-reflecting ice persists, the Arctic Ocean is warming at an accelerating rate. Ice shelves on the Antarctic Peninsula are breaking up and disappearing rapidly. 90% of the glaciers on the peninsula are now retreating. These changes are visible in the graphic from this fifth IPCC report in 2014. Additional evidence of the changing climate systems are seen in these events. Satellite images and surface measurements show that growing seasons are now as much as 3 weeks longer in North Eurasia and North America compared to 30 years ago. Southern plants and animals are moving into Arctic regions, while Arctic species such as muskox, caribou, walrus, and seal are declining. In Africa, for example, drought has increased about 30% since 1970. Marginal farmlands are becoming less productive as warmer temperatures evaporate available moisture. Plants and animals are breeding earlier or extending their range into new territory. In Europe and North America, 57 butterfly species have disappeared from the southern end of their range or extended the northern limits. Many plants may be unable to migrate as rapidly as conditions are changing. We now are forcing them to move much faster than they did at the end of the last ice age. Coral reefs worldwide are bleaching, losing the colorful algae they rely on for survival as water temperatures rise above 30 degrees centigrade or 85 degrees Fahrenheit. Marine ecologists worry that warming oceans could be the final blow for reefs, which are already threatened by pollution and overfishing, and for the fisheries and ecosystems they support. In this figure, we see the increase in sea levels over the past 140 years. Observe that the rate of change is increasing. Sea levels are rising owing to mean thermal expansion as well as the melting of land-based glaciers and ice fields. Remember that the melting sea ice would not impact ocean levels, only melting of land-based ice. From this graph, we see that global sea level has risen approximately 20 centimeters or 8 inches in the past century. This figure shows the reduction in glacier thickness since 1960. We are now losing glacier at over 120 centimeters per year. Arctic sea ice is less than half as thick and half as extensive in summer as it was 30 years ago. As more heat-absorbing water is exposed and less heat-reflecting ice persists, the Arctic Ocean is warming at an accelerating rate. This has created sharp declines in ice-dependent species, some of which have lost half or more of their population. Mountain glaciers are retreating, except where snowfall has increased, including in Montana's Glacier National Park. Climatic conditions for farming are shifting, and by 2050, wheat production may have shifted to central Canada. Scientists predict that if global carbon and other greenhouse gas emissions do not stabilize, the climate of Illinois will be similar to that of Louisiana. Precipitation in 2100 is expected to produce wetter northern winters and drier southern winters compared to recent averages, while drier summers are expected for most of North America. Values are averages of 15 climate models. As we mentioned in Chapter 1, the greatest increases in temperatures is expected at higher latitudes. The Arctic Circle is expected to see temperature increases of 7.5 degrees centigrade if no changes are made to anthropogenic greenhouse gas emissions. The fifth IPCC report cautions that further emissions of greenhouse gases will further cause warming and long-lasting changes in all components of the climate system, increasing the likelihood of severe, pervasive, and irreversible impacts on people and ecosystems. So what can be done? The IPCC report notes that we do have the means to limit climate change, but we must act now. The Pew report found that climate change is likely to cost between $5 trillion and $90 trillion by 2100, depending on how economic discount rates and other factors are calculated. In a study issued on behalf of the British government, Sir Nicholas Stern, former chief economist of the World Bank, estimated the cumulative cost of climate change equal between 5 and 20% of the annual global gross domestic product. In contrast, the Stern report estimated it would cost only about 1% of global gross domestic product to reduce greenhouse gas emissions now to avoid the worst impacts of climate change. The IPCC says it would cost even less, only 0.12% of annual global gross domestic product, to reduce carbon emissions the 2% per year necessary to stabilize world climate. Climate change denial, such as that by Trump and his climate change denying appointees, puts the world at a significant risk of ignoring climate change until it is too late to minimize its effects. There are many climate change denial claims, many of which have been shown to have been related to propaganda funded by major oil companies. In these two slides, we see some common climate denial claims and some responses from the scientific community. Take a moment and read through these false assertions and the scientific responses. Not everyone gets information the same way. For those of you who do not like to examine graphs and charts, click the link below to see a video that puts climate change data to music. The composition is called A Song of Our Warming Planet. For more information on climate change, check out these links.